Amazing. Good morning, everyone. Hello. Uh, in this session, I will walk you through how our team designed multi-tenant clusters to host different type of workloads with ensuring security across different tenants and applications. My name is Ahmed Bebars. I'm a software engineer at the New York Times in delivery engineering. And I'm so excited today because this is my first session as a speaker at KubeCon. And as you can see from these little icons, I'm a proud dad. I write a lot of Go for Kubernetes operators, applications, and other things, and also enjoy building on top of AWS. I'm also a scuba diver, so if you have recommendations, please hit me up, but only warm places. I don't like cold water. So let's dive in. Before we start, let me tell you a little bit about the New York Times. Our mission is simple. We seek the truth to help people understand the world, and we are doing this by aiming to build the essential subscription bundle for every English-speaking, curious person who seeks to understand and engage with the world. And the New York Times, news and journalism is the most recognizable product we have. We also have other products like games, consider like crosswords, spelling bees, and Wordle. Also have cooking for amazing recipes, and Wirecutter, audio, and The Athletic as well. So to get on the same page here are a couple distinctions to explain the upcoming sections. When I refer to a platform team, that I'm referring to delivery engineering. That's my team where we build platform, tool, and operate. When I refer to like a team, that's more of an engineering team. That's our amazing engineering teams across the company who are building applications and products that I just mentioned earlier in the previous slide. Here's our agenda for today. I'm going to cover a few topics. Why are we building internal developer platform at the New York Times? How did we design our container runtime platform? Why did we choose Cilium as a CNI? Day 1 operation, Cilium setup, and how are we using it? Day 2 challenges, and that's important. And what did we learn so far? So starting with developer journey. When we talk about developers, they do have a journey like customer journey. And here I try to identify the steps that most developer would go through when they start collect their business requirement until they deliver their application. So as you can see here, there are a few steps that developer would go through. Starts by an idea, followed by design, and another actions that each developer need to go through to deliver their applications. But you can notice here, I colored a few different steps because here where we can help and we can try to like get all of the similarities between these unique steps and help the developer with seamless experience. So let me give you an example. Here are few colors. Think of them as color palettes. And the ask is to mix them together. Imagine how your team to build this. So I'm going to pause here for about 10 seconds. It's going to be awkward while we go through this exercise together. And you can imagine like mixing all of these together in one canvas and how it's going to look from your perspective. That's awkward, I know. Okay, here we go. You can see here are the results. Every team builds their own perspective and their own unique image. So we give them some tools, but they build their own process that they go around. So the goal here is not to limit innovation because we know we have very smart people, but we want to help them to onboard to the process and make the process seamless and easier for them. So the goal here is to help engineering deliver their products to our subscribers. And we designed a platform to do that. And we start by like creating an application, template all of the resources needed for your applications to get deployed. Then we give you like the space where you can innovate and code and like build all of your business logics that you need. Then our centralized CI/CD system where like you can build and deploy your application. That's our runtime, which is the focus of my talk today. And then, of course, like you ingress all of your traffic and get it into your application. And most important, the monitoring aspect of it, because like you need to monitor all of the steps across. So we talked about why we built an internal developer platform. Now I'm going to talk about how we orchestrated our runtime setup. So we experimented with different setups for our cloud across accounts, and we found out that multi-account architecture is the one that we want to go with. That's for a few reasons. Basically, we can group workloads based on like common business purpose, in distinct account, avoid dependencies and conflicts. We also can apply different security rules between multiple accounts, development, production, number reduction, sandbox account. We can also limit the scope to impact, achieve resource independency, and also manage the cost across and have like different methods of cost allocation. So when it comes to build Kubernetes clusters, there's often a dilemma between like two things, and most of you may have went through that. First, are we going to use multi-single tenant cluster? So each team get the independency of like, hey, I can do my own stuff. I don't have to worry about others. There's no like noisy neighbor problem and all of the kind of resources. Or we go with multi-tenant clusters, which we can handle like more like less of operation overhead, and like we give them the space to innovate, but we can like optimize for cost. So we start to look into the main design consideration for building our Kubernetes clusters. Since we already have isolated accounts by default, we began considering network isolation. It's crucial to ensure that each workload has boundaries from other services, so we don't cross these boundaries unless it's defined. So by default, all communication between services is denied. Another factor we looked into was like role-based access control, and it's essential to have proper access. So when a tenant is onboarded into a multi-tenant cluster, they don't gain access to resources that they don't own. And last, we talk about resource management. That's important because like if we want to manage a multi-tenant cluster, we want to optimize for cost, and we want to make sure like everything is running efficiently. So after careful consideration, our design requirement, we came to the conclusion that multi-tenant clusters fits our use case. And we recognize this approach will help us achieve our goals and also to support creating our runtime environment. In order to do that, we started to build like Kubernetes cluster across multiple regions for disaster recovery and making sure that we have efficient workloads that can fail over between regions. And it's important to understand that there's no one-size-fits-all. This design worked for us. It may not work for you. You may have to figure out a different design. So we're talking about network isolation, but we're still running in multi-tenancy. So we need to ensure that we have the right networking tools in place to ensure that there's no boundaries being crossed here. And that's where we started to look into different CNI options, and Cilium was the one we decided on. First, let's talk about performance. As you can see here, like this is from the CNI benchmark blog on Cilium, and like you can see few components over there are being removed in favor of Cilium, and that's of course mean like there's a performance overhead improvement that we can see, and using BB filter for routing means we shift traffic filtering to the kernel, and that improves the process. And Cilium promised this originally, and there are different CNI benchmarks that shows this, and you can go review the original benchmarks on Cilium blogs for more detailed comparison between different options. On top of that, one of the other considerations between network isolation, we want to make sure that we have the right things in place. So Cilium Network Policy is a great extension of the Kubernetes Network Policy API. It brings such different policies from like L3, L4, and also L7, and support for DNS, and also have identity for services. But also we have policy enforcement modes, where the default mode is good for most cases where like everything is allowed by default unless you specify something, and then like other things are restricted. And there are more like always mode. I believe that's where like everything is restricted by default, and you can enable this for like more secure environments. But you can also see here like there's cluster-wide policy, which is streams the process of you want to apply something across all of your applications, despite where where your application is hosted, and it doesn't matter which namespace you are in. Then observability is important. So like you heard about Hubble. So here's like a small diagram from Hubble UI. That's where like you can see the service mesh and the network, how it works, traffic routed between different services. But the most important from the Hubble UI is the flow itself. So if you look deeper into the flow, you will see like full rich information about every single packet traverse between like different services, and that's important. So we can build like any understanding of like how traffic is flowing between services. But also like it comes with a lot of metrics out of the box. So you can see like we have here endpoint states. We have like traffic drop, traffic allowed, all of the kind of metrics that allow us to observe more for our clusters. So how are we using Cilium? So as any organization, we are using Terraform for cluster provisioning, but there are a couple things. When we start to use Terraform, like EKS, where we build on top of that, okay, comes with CNI itself and comes with kubeproxy. So we need to remove that, and then we need to install Cilium as a CNI, and then have all the process there. So there are two ways we can do that. We can even like just provision our clusters, do the process manually, or we can just script it in some way. So we don't prefer to do it manually. So we created just like a small script that does all of that for us when our cluster is being provisioned. So after the cluster is being provisioned, there are a couple of things that we need to go through. So that's a resource. We'll provide some base Helm values, and like a script will get all of that sorted, and we'll install Helium for us and mark all of the nodes as ready. To go through the script, what we need to do. So first, we need to remove the AWS CNI. And after we remove that, we need to remove the kubeproxy, and then install our CNI configuration, which like you can see here, we have some ENI config and also like some other subnet tags. And then there's like some masquerading configurations that we need to install. So you all heard about IB exhaustion, and that's where we use the ENI mode for Cilium on top of EKS. So there are a couple things here. First, on that side, you'll see like we have like 10 IB space, where like this is where it gets attached to the Cilium agent and the nodes themselves. And then like, because we are running a multi-account architecture, if we kept using the 10 space, we're gonna run out of IBs, which is like gonna happen quickly. So we started to provision like other subnets with like 100 space that allow us to communicate and have more pods. And because like we are in a shared environment, that we need to ensure that like we can scale. So a couple things here to unpack this. That's another subnet, but like you can see a couple things here. You can see like a couple ENIs, and you can see multiple IB addresses and prefixes. So one of the things that there's a limitation when you run EC2 instances, that you have limits of the number of ENIs that you can attach to the instance. And depending on which type of instance that you can run into, that may be problematic for like shared clusters. So one of the things that Cilium supports is IB prefixes. Basically, like you can get the same number of like ENIs, but instead of having like a single IB or a few IBs per ENI, you can have multiple prefixes, which allow you to expand, I believe, 16x the amount of pods that you can have on a node. And we run different size of nodes as well. So how's the process starts? Like you get an account, the process is completely automated. After you get that, there's like a CRD will get created. We have an in-house operators that will take this CRD and convert it into like Kubernetes resources. You start by default namespace, roles, and all of the things that tie it back to your cloud account that gives you access. And then like more important, we talk about Cilium network policy. So we start by a network policy that only allow traffic back to your accounts. So like, because we are running in shared clusters, we want to ensure isolation. So all of our accounts are connected together because we are shared, but we still want to ensure that your services only can talk back to your account when you need to extend capabilities. But there are other possibility of using Cilium network-wide policy were like things like, if you are in AWS, you are familiar with this IP address, which is the instance metadata service. So we want to make sure that we block this. We also want to make sure that we block other IP range that you are not allowed to talk to unless like we give you access to do that. So far, so good. Everything is great. And then you have the calm before the storm. That's where like our day 2 operation gets in. So everything is running okay, and like we're onboarding services and everything is great. Before like telling you about what happened and how we survived that, let me tell you about our ingress model first. It's a critical service that we have all of our traffic going through Envoy and then goes to upstreams. So we just onboarded our critical service into our cluster. And then like traffic is coming there. But then this happened. And then you can see like traffic is still coming, but like there is something happening and like we can't understand what's really happening. And like we looked through it and like seems like one of the buds is not working for Envoy. We can't blame Envoy for sure, but we aren't sure. So we remove the bud, everything works, and then like we're going forward. But we weren't sure like what exactly is the problem. So we started to investigate. First, is it Envoy? So Envoy possibly like have misconfiguration and this bud is not behaving as expected, because once we remove it, everything works as expected. But then we discovered something that also might be DNS, because we started to look into that specific bud and like we figured that it's not getting all of the DNS requested it needs. But like it was a weird situation because not every time it's not gonna get DNS. Sometimes yes, sometimes no. So it seems to be like more of a networking. And that's where we decided to look further into Cilium to understand like what's really happening. So the bug hunt will start, and we'll try to use all of the tools at our disposal to understand where's the problem. And Cilium gives us like a sysdump tool, which allow us to dump everything that happens from logs and configuration into like log file. It's huge, so don't try to look into it, but it's big. So we went through like reading and understanding like how things are working there. And then we found like a couple things like Cilium node CRDs, which is like the way that Cilium manage resources in Kubernetes cluster. That's where like it has like, as you can see here, like ENI addresses, it has like the pool of IBs that it's using and all of that kind of stuff. And what we found is there's a missing IB. So here what happened. Like we have an Envoy proxy that has an IB in the 100 space. But then like we look at the node and this IB is not there. So there's something wrong, and we're trying to understand like what's really happening there. And looks like this was happening. So the use case there was the IB gets attached to the bud, and then it gets marked as it should be released. So in Cilium, there's a feature that allow you to release excess IBs. So what happened is like a bud get created, an IB is being attached, and then like Cilium think like this IB should be removed. So start to remove the IB. And that's where like the bud was already starting successfully passing all the props, but then gets in a bad condition because it can't communicate. So it goes bad. And then like to fix that, you just like simply go to the UI, adds IB, and everything works. But like that's not gonna work for us because not every time at 2 a.m. we can go and like add this IB back. So also like when you look at here, you simply can disable the excess IB release, but we are talking about IB exhaustion, so we want to make sure that we release all of the IBs. We don't want to keep them. We are running in a shared IB pool, even in the cluster, so we want to make sure that all IBs are released back. And like you can, I don't know if you can see the logs, but like you can see like we're talking about bud creation time, and then like IB is getting released after. So that was the intermittent fix, which like, okay, let's turn it off for a second, let's make sure everything is stable, and then move forward. But then we went in to look into the code to understand like what's really happening and read through and try to identify where's the bug. And that's where community helps. So looking in the code, trying to understand what's really happening, we found like Datadog already contributed the fix to that. I think they have a talk today. I'm not sure if it's about the same thing, but basically there was an edge case here that happens when like a bug getting assigned and then getting released. So like what's being introduced here, and this is from the GitHub pull request to fix this issue, is like some sort of a handshake where like you assign the IB. When the bug gets terminated, there's like a handshake between the Cilium agent and the operator to update the cache and make sure that like the IB is going to get released and it's not going to be available in the cache, so the agent wouldn't reassign the IB again. And that was our hunt. So what do we learn so far? We learned that eBPF is powerful, so we started just by using it as a Cilium, as a CNI, and networking, and have like all of this network policy and looking forward for more other opportunities where eBPF can be helpful. Observability is very important to us to understand like all of the traffic that we need to get from our clusters and platform. And at the end, like we appreciate the community. Like we found something wasn't working for us, but other people who already contributed to the upstream and solved the problem as we upgraded to the next version of it. And I believe that's about all. And I'm joined here by my colleagues, so we're gonna have like other talks from the New York Times talking about Argo and how we deployed this in the New York Times. And also we're gonna talk about OBA later on Thursday, I believe, and using this for testing and GitOps. And that's all. Thank you.
Testing 1, 2. Testing 1, 2. Yeah. Hey, Marco Hemken here. Just a quick question about your pod network. So you're not using an overlay network for the pods. You're using the VPC network for the pods.
That's correct.
Wow. Okay.
Yeah, we're using a secondary CIDR in the VPC where like a CIDR get assigned to the node. That's the original CIDR across all of our network cross accounts, but we have a special secondary CIDR with the 100 space with like just assigned to the pods. So when traffic gets back outside of the account, gets with the 10 space, but like inside the clusters, it always has the 100 IP addresses.
Yeah. Hello. Yeah. For multi-tenant purposes, do you plan to use different CIDR private addresses for the pods part? Because you seem to use only the 164 subnet for the pods. And do you plan to split it to get really isolated CIDR IPs for your tenants?
I'm not sure that I heard the question. If you don't mind repeating it, please.
Yeah. For the private pods, you've got a 164 CIDR address plan. Do you split it and isolate it for every tenant you have, or you just use the 164 for all the pods?
So if I understand the question correctly, do we split the CIDRs between tenants across in our clusters? No, we don't. So like if you have your own account, you get your own CIDR, that's in your VPC. But in our runtime environment, we have like a big CIDRs that we use, and we just like give you the space in any address that we need to. And then like we use like your namespace, your identification of service, all of the kind of to understand like where are you going to, and like understand like how we can egress and ingress traffic to your cluster, to your services.
Hi. Yeah. So does this mean that Cilium does natting on individual nodes? Like normally when you use Azure CNI or Azure network plugins, it's like a one-to-one mapping. So it is already allocating the IP addresses while the building of the cluster, right? But when we have, I think ViewNet or some other CNI, I don't remember, which does a netting inside. So when you see there's a multiple nodes you can spin up, it's not dependent on the fixed network, like, it's like a one-to-one mapping kind of stuff. So does Cilium does the same kind of strategy, like netting of the IP addresses? So when you want to troubleshoot, you will see some different IP address. It's not the one, the actual IP address, right?
So if I understand the question, like you are asking if Cilium is netting our traffic from buds to other accounts, is that the question?
Yeah.
Okay, so when I mentioned, I referred to that earlier. So all of our nodes get 10 address space. So that's like if traffic is crossing boundaries to a different account, that's what the IP address will be showing out. So like you get like 10 space IP on the other account. But if traffic is egressing between different buds, we will only see the 100 IP address there. So Cilium is not like netting cross accounts, but it's netting around the nodes themselves. So we can see traffic flowing between buds on a specific range, which is 100 space, and then like the 10 space is just like cross account. And if for sure, if we're crossing public internet, there will like be like public IP addresses when how it's gonna get egressed out.
Okay, thank you. Another question. So as you said that you have removed the kube proxy daemon set and things while deployment of EKS. So after implementing the cluster and it's live and there's some issues on the pod-to-pod connection on any worker nodes, right, or any problem. So that means that AWS will not take responsibility to support that. It's us, or it's like the developer has to find the root cause with this and has to provide the fix or go to the community, check with people, but that's a time consuming, right? So does Cilium also have a licensing kind of stuff that you get support normally?
So if I hear it correct, you're asking if once we remove kube proxy and components from like EKS, like what's the role for AWS and Cilium in this place? So like I'm not sure about like AWS, but like since we removed things that they already provisioned earlier, they wouldn't support that out of the box. And for Cilium, we basically support that. So we understand the process, we understand what's happening, and like we need to work out with Cilium. I know that Cilium has other offering as well. So I think I ran out of time. So thank you all. Appreciate it.